In this next series of videos, we're going to begin generalizing roots to roots that have indexes greater than 2. Now, recall that in either case, whether the index is a 2 or not, that with a root, we're trying to find a base. And I'm going to have to give you the exponent and the power for you to do that. We're going to use the radical symbol to say we're looking for a base. And then the index will be the original exponent, and the radicand will be the original power. So this is saying, can you find a base for this exponent that will return this power? As an example, this is asking us to find a base. When the exponent on that base is a 5, we're going to get a 32. And that base is going to be a 2. Because if our base is a 2, and if that base has an exponent of 5, then once we multiply 2 to itself 5 times, we're going to get 2, 4, 8, 16, 32. We're going to start by simplifying some common roots. For example, here we have a case where we're looking for a base. When we multiply it 3 times, we're going to get a negative 8. And a good base is going to be negative 2. That is, negative 8 is negative 2 times negative 2 times negative 2. So the cube root of negative 8 is going to be negative 2. And again, we can always check whether that's true. Here's another case. Notice this time our index is even, and that's going to be important in a minute. So here we're looking for a base. When that base has an exponent of 4, we're going to get a 16. Sometimes you can just see what it should be, but if you can't, keep in mind you've always got prime factorization. If I prime factor 16, I see I have 4 factors of 2. That is, 16 is 4 factors of 2 being multiplied. So this is asking me what's the base, which when it has an exponent of 4 is going to return 16. And that base, as you can see, is a 2. And then I can always check by saying, well, if the base is a 2 and the exponent is a 4, do I actually get 16? And I do. Now, it's true that negative 2 with an exponent of 4 also gets us 16. So why didn't we say it was negative 2? And the answer is, when the index is even, we're only interested in the positive base. This is often known as finding the principal root. When the index is odd, we don't have this issue, but when the index is even, we're only looking for the positive base. Try this one. Now, there isn't any integer that works here, but I do realize that I can think of 16 as 8 times 2, and the cube root of 8 is going to be 2, because 2 cubed is 8, and so I'm going to have a factor of 2 outside the root, and this factor of 2 is going to be stuck inside the root. Try this one. Here's a case where I think I'm going to use prime factoring. 54 is 2 and 27. 27 is 3 and 9. 9 is 3 and 3. So I can see I get 3 factors of 3 and 1 factor of 2. And the cube root of 3 cubed is just going to give me a 3, because again, that's just asking what's the base, which when I cube it, I'll get 3 cubed, and that's just 3. So we'll have a factor of 3 outside and a factor of 2 inside. How about this one? So our radicand is a pretty large number. I don't have any factors of 2. It's not even. I don't have any factors of 3. If I add 6 and 2 and 5 together, I get 13. 13 doesn't have a factor of 3. But it does have a factor of 5, so I'll start by factoring out a 5, and I'm left with 125, which still has a 5. I'll factor out a 5, I get 25, and then that's 5 and 5. So I see I have 4 factors of 5, which means 625 is 5 to the 4th, and that will simplify to simply 5. Well, that will conclude this video, where I've given you some tools for simplifying common roots when the index is greater than 2.